In this video, we're going to recreate Sonic's iconic spin dash mechanic in Godot. We're going to build this where you hold your charge button, and when you release it, the distance and speed you roll is based on how long you were charging up for. As usual in these videos, I do have some basic setup right now. I have a basic level set up, and in my character, I have a few animations that are already set up. I have idle, jump down, jump up, run, and the spin animation already set up. In our project settings, I have roll on my left mouse button, and I have a basic script already set up for my player. It's just accounts for our different animations and our movement. So when we play, this is what we can do right now. We can just move around and jump. Left clicking doesn't do anything. So we are going to handle that all in updates to our character script. So we're going to need some additional constants set up while we're working on this to make this work. So we're going to need a max roll speed, which is going to be equal to 800. Constant for a minimum roll speed, which is going to be 50. You can, again, adjust any of these variables that you would like. We're going to have a roll friction constant, which is going to be 0.99, and we're going to use this for a gradual slowdown effect. We're going to have a max charge time, which is going to be 2, and a constant for our max roll distance, which I'm going to make as 500. You don't have to have this if you don't want, but I want my character to only be able to roll a certain amount of distance. We're going to need on-readies for the sprite and our animation player. We're going to add a couple of other variables. We'll do an enum actually first for our state. So we're going to have a small state handling mechanic as well. So we're going to have a normal state, a charging state, and a rolling state. And then we're going to set up some regular variables. So our current state will be equal to our normal state. Variable for our charge time, which is going to default to 0. We're going to have a roll velocity, which is going to be equal to vector2.0. A variable we're going to call facing direction, which is going to be equal 1. So this facing direction is going to be a variable. It's going to be -1 for left and 1 for right. And we're just going to store which way the player was last moving. And we're going to use this so we can preserve that value when we're not pressing any direction keys. So we never want it to be 0, or else our guy will never be able to roll. And then we're going to have a roll start position, which is going to also be a vector2.0, and then a roll distance traveled, and that's going to equal to 0. Okay, so let's get our base methods set up so that we can start filling all of this out. We are going to need our physics process, even though we will make some changes to it. We have this update animation method right now. You might handle this a different way, but this is how I'm going to handle it. We're going to need a handle normal state, which will take in a delta, a handle charge state, which also takes in delta. We're going to have an enter charge state, enter roll state. We're going to have an exit charge state and an exit roll state. And that will actually wrap up all of the methods that we're going to need. Let me just correct some spelling issues right now. And I actually did miss one. We also need to handle a roll state, which gets delta, and we will pass here as well for right now. So we can go up to our physics process, and what we're going to do here is we are going to match on our current state. So this is going to be our state handling right now. So if we're in our normal state, we're going to handle our normal state, pass in the delta. If we are in our charging state, we are going to handle our charge state. And if we are in our rolling state, again, we handle our roll state. And we always want to have this move and slide and update animation inside of our physics process, but I'm going to move all of this code for right now. So let's cut this out, and this is going to be our normal state code. We do need to add a couple of other things here. So in the direction, we also need to update our facing direction. And we're going to have this equal to the sign of our direction. So if we have a direction, that means we're going to be pressing our arrow keys in either direction. And then the sign is going to guarantee that we're going to get a -1 or a 1. So left will give us -1, right will give us 1, and this is going to prevent us from ever getting that 0 value in facing direction, so we can preserve the way that we're actually rolling. And then in order to make sure that we can actually enter our charge state, we need to check on the input and is action just pressed, and we look for roll. We also need to make sure that we are on the floor. And if we are, then we can go enter our charge state. We can actually move this. Let's bring this up into our physics process, since this is, we always want this, right? Like we always want to make sure that if we're not on the floor, we're applying our gravity. So this can actually just be in the physics process, and that will prevent us from having to repeat all of this code in all of our states. So now in the handle charge state, we are going to set our velocity.x to 0. We're going to look if our charge time is less than the max charge time. Our charge time plus equals the delta. And then we check for an input, and is action just pressed, roll. We're going to enter our roll state. Then if not on the floor, we are going to exit the charge state. In handle roll state, we're going to get our roll distance traveled, and we are going to add the absolute value of the velocity on the x-axis multiplied by delta. Then we're going to create a variable that's going to be a Boolean, and it should stop. So what this is going to do is if we hit our max distance, if we click a button, or we're moving our arrow keys, or our velocity is less than our minimum roll speed, then we are going to actually stop. So this is going to be kind of a lengthy if block here, because we're going to have a lot of different scenarios that we would want to stop. So the first one is going to be the roll distance traveled is greater than or equal to the max roll distance. Then we're going to do an or input.is action just pressed roll. So if we're left clicking again, or the absolute value of the velocity.x is less than our minimum roll speed, or the input.is action just pressed left. Oop, that didn't go through. Is action just pressed. We want to do left, and then or the input is just action pressed for our right. So those are just my move left and move right input mappings. So they might be a little bit different, or you might call them something different in yours, but either way, what we're going to do after this is we're going to mark should stop equal to true. And then if we should stop, we're going to exit our roll state and we return. We don't want to keep moving down this code block. Otherwise, we're going to get our velocity on the x-axis, and we're going to get the roll velocity on the x, and we're going to multiply it by our roll friction. Then we're going to get a variable that I'm going to call steer, and it's going to be our input dot get axis on the left and right input mappings, and multiply that by 0.3, and then we get our velocity dot x plus equals the steer times our speed, which is a constant that was defaulted by Godot, and the delta. Then we're going to enter the charge state. So the only thing we do here is we set our current state equal to state.charging. The charge time is 0, and the animation player is going to play my spin animation. In the roll state, the current state gets set to our state.rolling. The roll start position is going to be equal to the global position, which is going to be the global position of our character. And then the roll distance traveled back to 0.0. And we're going to get a variable that we're going to call the charging percentage, which is going to be equal to a clamp on the charge time divided by max charge time, or 0, and then 1.0. Then we're going to get a variable for our roll speed, which is going to be equal to lerp on the min roll speed, the max roll speed, and our charge percentage. Our roll velocity on the x-axis is going to equal to our roll speed times the facing direction. So this is why it's important that we're going to be grabbing that facing direction and setting it properly, because if it was 0, we wouldn't be moving. Then our velocity is going to be equal to the roll velocity. And lastly, we need to make sure that we're going to be playing our spin animation. In the exit charge state, we just have to set our current state to go back to the normal states. So we can go back to handling our normal movement. And then the charge time is back to 0. And then exit roll state, we need to do something similar here where the current state is back to our normal state. Roll velocity needs to be reset to vector 2.0. And the roll distance traveled needs to be reset to 0. And the last thing we have to do after the roll state is we also need to make sure that we're handling our animations right. So we're going to check on our current state, and if it's in the state charging or our rolling state, we want to return. We want to make sure that we're staying in our spin animation. Let me just do a quick once over here before we test this out to make sure that everything is looking right. Okay, I think, yeah, the absolute value here should be like that. We're only absolute valuing on the velocity.x, not this entire thing here. And then handle charge state. This actually shouldn't be just pressed. This should be just released. So when we release our roll click, that's when we want to enter our roll state. And all that being said, we should be able to play this now. There we go. I can charge up, and when I release, we move. But if I do it a little bit slower, I stop. Then if I hit my left key, our guy stops, or if I click, we also stop. There we go. It's a little kind of confusing. I think I'm going to add a charge bar above just visually for us to see how long we're charging. And then we're actually going to dress this up. We're going to make a smoke effect, and we're going to add a flash effect while we're charging. So just to quickly add this progress bar, we're actually just going to do this programmatically. We're not going to make this in the editor or anything like that. So let's just make a method where we can call it add charge bar. And I'm going to copy and paste some of this in here right now just to speed these things up. But I'll explain what we're doing here. We're just creating a progress bar, giving it a name and adding it to our scene, and then just setting some position values here. And then in our ready method, we just have to add a charge bar. And then we're just going to add a couple of things inside of our states. So in our handle charge state, right below where we're checking here, we're going to get what we call the charge percent. It's going to be equal to the charge time divided by the max charge time. And we're going to get the charge bar. We have to do the $sign because that's the name that we're giving it here. We're going to change the value of it equal to the charge percent times 100. In our enter roll state, we are also going to add the charge bar here, and we're just going to hide it. After we're entering the roll state, we don't want to see this. Inside of our enter charge state, so right above, we are going to want to show it. So let's show this, and then we're going to change the value to be equal to 0. And then the last thing we do when we exit the charge state, we just want to hide the charge bar. Okay, so let's see this in action now. So now when I click, you'll see, boom, you can see now I'm actually able to track how long I'm holding it. We also have a max charge value, so nothing more is happening the longer I click here, and that's the max that we will see. Well, let's actually make this a little bit prettier. So we are going to go back to our character, and we're going to add an animated sprite. We're going to call this our smoke sprite. We're going to go create some new sprite frames, and let's go in there, and in the default here, I'm going to use this smoke.png. I will link all the assets in the description, but let's go grab this here, and it's going to be 6 on the horizontal, 1 on the vertical, and we are going to select all of these and add the frames. So I'm going to position this. I want it to be behind my character sprite. And I'm going to position this I think something like that should be good. Let's crank the FPS up to 12. Now we can play this, and this is what it's going to look like as we're spinning. Obviously we're not spinning right now, but this is what the smoke is going to look like when we play it. So let's save this. We'll go back to our character body script, and we're going to want an on ready for our smoke sprite. And in the ready, if we have the smoke sprite, we just want to hide it. We don't want it to be showing until we're actually clicking to start our roll process. We're going to add a method here. We're going to call update smoke position. So we need to make sure that we're properly flipping the smoke and putting it in the right place whenever we're moving left and right. So if we have a smoke sprite, the smoke sprite.position.x is going to be equal to, so we need to go back into the 2D, and we need to make sure we have this note on the x-axis here. So this x is -15. So in our character, we want it to be 15 if the sprite.fliph, else -15. And then we can also just hard code the smoke sprite's position on the Y to be equal to -9, which will also match right here. Then we do smoke sprite dot fliph equals sprite dot fliph. So we're going to be matching the smoke sprite's ability to flip based on whether our character sprite is flipped or not. Then in our enter charge state, get rid of the sprite frames here. So let's go to enter charge state. And at the very bottom here, we can do our if smoke sprite check. Not really necessary. We know it's going to be there, but still, we'll do a smoke sprite and we will show it. Then we're going to do the smoke sprite dot play, and we're going to do the default. And then we can update the smoke position. Then in our exit roll state, we want to hide this also. So we go, if we have our smoke sprite, we're going to smoke sprite hide it. And we are also going to stop it. So we stop playing our animation. So let's go check this out now. So now when I'm clicking here, we're smoking and we're still moving. We're still seeing the sprite for the smoke even when we're rolling, which I kind of like. You might want a different effect or different type of smoke when you're actually rolling, but I think for now that this looks pretty good, and we can give you the flexibility to add what you'd like. And I think finally, adding a flashing effect while we're charging will just give this a little bit more life. I think right now it's still pretty basic. So let's just add a couple of things. We're not going to need to add much to get this flashing effect, but let's first go to our handle charge state. And right below the charge bar value stuff, we are going to set a minimum flash speed and a maximum flash speed. So the minimum is going to be 5.0 and the max flash speed is going to be 20. We need to get a current flash speed also, which is going to be equal to the lerp of our min flash speed, our max flash speed, and then the charge percent. So we're going to tie the amount that we're flashing to the charge percent. Then we're going to get a flash intensity variable, which is going to be equal to the sign on the time dot get ticks msec, so milliseconds. Then we're going to times this by 0.1 times the current flash speed. And then outside of this, we add 1.0, and then completely outside of the parentheses, we are going to multiply this by 0.5. And then to bring this all together, we're going to modulate our sprite. And we're going to bring this a color on 1.0 plus the flash intensity, comma 1.0 plus the flash intensity, and 1.0 plus the flash intensity again, and then another comma and just 1.0. Then when we enter our roll state and we exit our charge states, we need to reset the color to not have the flash intensity. We don't want that in every state just while we're charging up. So when we enter the roll state, we just want to reset our color to just be ones across the board. But we need to do sprite.modulate to be equal to that color. And let's just copy this line, and we want to add it to the exit roll state as well. So let's see this in action. There we go. We're flashing. And then as soon as we start rolling, we stop. Cool. And the last thing I'm going to do, I think again, completely optional, is the smoke speed can also scale up. So let's go in to the enter roll state. So right here. And then after we're playing our animation, we can do, if we have our smoke sprite dot show, and then we can do the smoke sprite, the speed scale. We're going to lerp it on 1, 5, and our charge percentage. Then we're going to also add this before the steer calculation in our handle roll state. So our steer calculation is right here. Let's add, again, we're just checking to make sure we have the smoke sprite. We're going to get a variable called speed percent. It will be the absolute value of the velocity on the x-axis divided by the max roll speed. And then the smoke sprite speed scale is going to be equal to the lerp, again, on 1.0, 5.0, and then our speed percent. And then lastly, when we exit our roll state, we need to reset the speed scale back to 1. So let's go to the exit roll state. And after we modulate here, actually, we can just put this, we're already checking if we have a smoke sprite here. So let's just go to our smoke sprite. We can speed scale and just reset it to 1.0. So now, the longer we're holding it, the more intense the flashing is going to get. It may be really subtle right now, but if you want to see it, you can extend the amount of charge time. So if we want to check this out, let's go up here, and the max charge time, I don't know, let's just call it 10 seconds. And let's update the lerp here to be, I don't know, we can do it to 20 and 20. Let's just see how this is going to work. All right, so yeah, you can see the smoke sprite is going a little bit faster there, but if I hold it a long time, you're going to see it just rapidly start kicking. See, it's going real fast. So I think it looks a little bit better in the other percentages that we had, with it only being on the 5 here. And the charge time is just, it's really long. I mean, we can put it at 3, maybe it would be a little bit better. But this is a quick way for you to implement the Sonic Spin Dash into your game if it works. I hope you actually learned something, and let me know in the comments if you want to see me cover any other specific mechanics from old school 2D games.